Again, this question is asking where is it defined, and then they want us to expand and simplify. So remember the word defined means where is it possible. If we're dealing with square roots or fourth roots or sixth roots or even any even powered root, you know that you can't take the square root of a negative. So if we check our positive values for b and our negative values for b, if I plug in a positive value for b, it's okay here. It's also okay here. So positive values work. If you plug in a negative value for b, we would take a square root of a negative, and that would be bad. So when we go to say where is it defined, b is only defined when it's bigger than or equal to 0. Now that we have that, we can FOIL first, outside, inside, and last. 7 times 3, 21. 7 times negative 5 root b. Again, you multiply the coefficients and you multiply the radicals. Now the coefficients will be 7 times negative 5 will give you negative 35. And there's a root b, and since there is no radicals there, you can think of it like a root 1. You will just be left with a root b. Because I multiplied 7 times the minus 5 root b's. So 7 times minus 5 is 35, and then you still have a root b there. On the inside, I'm going to have 2 times 3, which will be 6, and I'll still have the root b. And finally, the last ones, 2 times negative 5 will be negative 10. Root b times root b would be root b squared. Simplify and combine things. We're going to get 21 minus 35 and 6 will be minus 29 root b's. And the square root of b squared will just be b. 10b. Technically, because b has to be bigger than or equal to 0, you don't need absolute values here. But again, I'm not going to worry about when you need absolute values when you simplify them and when you don't. In this case, since b is bigger than or equal to 0, you wouldn't need the absolute values. Normally, when you take the square root of a b squared, you put absolute values around. But those are just technicalities. There's our final answer. We can't combine anything because 21 and 10b aren't like terms. A root b and a b aren't like terms. So we are done. All right, second one. We have a difference of squares. Maybe you can recognize it or maybe not at the beginning. And then we're multiplying something squared. I'm going to just take the time to write this out again with the second one written out twice, because that's what squaring means. First, outside, inside, last. But if you recognize this as a difference of squares, you'll notice that your inside and your outside will simplify and cancel out. So it's just going to be the first ones multiplied together, which 3 times 3 would be 9. Root x times root x will be root x squared. And the last ones, root y times root y will be root y squared. I'm going to just keep that in brackets right now because I have more operations to do. And I'm going to FOIL these ones as well. A root x times root x will be root x squared. Root x times 5 root y, we'll multiply the numbers in front. That'll give us 5 times 1 is 5. Root x times root y will be root xy, because we multiply inside the radicals. The inside ones will get 5xy again. And finally, the last ones, 5 times 5 is 25y squared. And I kept that whole thing in the second one in brackets as well, because this sign here says we are supposed to subtract all of this. So I have the subtraction. I need brackets there because we still need to subtract all of it. What's the square root of x squared going to be? Just x. So I have 9x. Square root of y squared is going to be just y. Minus. This minus is going to go to everything inside there. I'm going to first simplify the inside, and then we'll do the minus afterwards. Square root of x squared is just x. The 5xy and the other 5xy can be put together to be plus 10xy. And 25y squared will just be 25y. Now this subtraction is going to go to each thing. So what's going to happen if I have 9x minus x? I'm going to be left with 8x. Minus y minus another 25y minus 26y. And minus 10xy. Because I had a 9x here, and I'm going to subtract 1x. Yeah. Because you're going to subtract each of those things. This is our final answer. One thing we didn't do in this question at the beginning is say where things were defined. Looking back at our original question, we know we can't take the square root of a negative. So if I look inside the square roots, can you see that x can't be negative? Because then I'd take a square root of a negative. And y can't be negative. Then I would take a square root of a negative. So this is defined only when x is bigger than or equal to 0 and when y is bigger than or equal to 0. So a lot of algebra, right? We wrote down those notes. How do we multiply mixed radicals? That's very important. Then we always simplify. Some things that are going to be tough in this one and mistakes that you're going to make is when you're subtracting something, you're subtracting all of it. So I keep brackets around all of it until I'm ready to actually subtract. And then I can distribute the negative to each thing at that time. Okay, the questions for this one are question number 8. Just question number 8.